For this question, we are asked to find the angle between the line CD and the plane ABED. So if you look at the diagram over here, actually the angle that we are required to find is this angle CDM, indicated by the red angle alpha here. So I'm going to draw the triangle CDM over here. So this is the angle that we are asked to find in part 1, and none of the length is given, and hence we are going to look at some of the triangles on this original diagram to help us find some of this length. So to begin with, we're going to look at this triangle AMC or CAM. This is a right angle triangle with length 5 cm and the length of AC to be 10 cm. Right, it's given over here that the side of each of the triangle ABC is 10 cm. So we have 10 cm, we have 5 cm, and what we're going to do is that we're going to apply Pythagoras theorem to this triangle ACM to find the length cm. So solving for the length cm, we found the length cm to be square root 75. So I'm going to transfer this over here. So now we have one length of this triangle, square root 75. Next, we are going to find the length of this triangle DM. We're going to look at this triangle CDA. We know that DA is given as 12 cm. AC we know is 10 cm. Again, you would have noticed that the triangle CDA is actually a right angle triangle. So likewise, we're going to apply Pythagoras theorem to this triangle ADM. Alright, so applying and solving for the length DM will give us a value of 13 units. So we're going to transfer this 13 units over here. So now we have 13 units and square root 75. Now with these two lengths, we would now be able to solve for the unknown angle alpha. If you look at this triangle CDM, we have two sides. This side is opposite to angle alpha, and this side is adjacent to angle alpha. So therefore, we could apply Tuakaso, and tangent alpha will be equals to opposite over adjacent. So there we have it. Tangent alpha equals to opposite square root 75 over adjacent 13. To solve for alpha, we do an arctangent of square root 75 over 13, and to give us an answer of 33.7 degrees, rounding off to 1 decimal place. Next, we're going to move on to part 2 of the question. Part 2 requires us to find the angle between the line CD and the line BE. So now we have the line CD over here. This is the line CD and the line BE. Now if you look at the original diagram over here, you would have noticed that the length CD and BE does not meet. So what is the angle we are talking about? So let me just explain a little bit. BE, we know that is parallel to AD. So therefore, the angle between CD and the angle between the line CD and the line BE will be the same as the angle between the line CD and the line that's parallel to BE, which is AD over here. So in other words, we're going to look at this triangle CDA and find the angle beta indicated in blue over here. So I'm going to draw the diagram of this triangle CDA. Beta is the angle that I want to find, so I color red on this diagram. The dimension that I know AD is 12 cm. I know that AC is 10 cm. So with these two lengths known, I can go on to find the angle beta. Now the length AC is opposite to beta, and the length 12 is adjacent to beta. So we know that tangent beta is equals to opposite over adjacent. To find beta is simply the arctangent of 10 over 12. Using your calculator to evaluate this, you will get beta to be 39.8 degrees. Therefore, the angle between the line CD and the line BE will be 39.8 degrees.